Coming? All right, welcome everyone. Let's begin. Are the screens locked? Okay, good. Let's look at these announcements. 72 hours from right now, you'll be here in this room working on the exam, right? You'll be laughing at how easy it is, because you know the material that well that each of these problems, I hope, are just going to seem like nothing to you. I'm writing the exam to the approximately the same level as the homework assignments and the examples and the in-class exercises. So my hope is that, between the lectures leading to the in-class exercises and the in-class exercises leading to the homework, I hope it will be a very smooth transition for you. Of course, how hard you perceive the exam to be is obviously a function of how much effort you've been putting into the course so far. But in any case, we're going to be in this room for exam 1 on Sunday, March 6th, and also that day, homework 6 is due. I'll take the key to that assignment home over the weekend so that if you've got questions, I'll be able to respond to them. And of course, I also have office hours this afternoon if you'd like to stop by. Any questions related to the announcements? All right, today we are going to continue with comparing alternatives. You'll recall that during the last 2 lectures, we've been comparing things according to the present worth analysis method. And so we'd have 2 different options. Sometimes they're the same length, sometimes they're a different length. These cash flow diagrams we're comparing. And we've been trying to take all of the money to the present, and then our criteria has been whatever gives you the most profit in the present is the option that you should choose. So let's just review what we saw in the last class when we were comparing things that had a different useful life, because those are sort of a 2-step process. On Sunday of this week, it was easy because both of the options had the same number of years. But if they have a different number of years, one of the ways you can handle that is the least common multiple approach. And that's what we used when we were assuming the cash flow could be repeated. So here's just a picture taken from our last lecture where we had one of the option lasted for 6 years, another one lasted for 9. And so we did 3 cycles of option A, 2 cycles of option B, and then they both ended with the same number of years. The other approach we looked at was contract services. And remember, that's the situation where instead of buying the thing again, you just go to the market and find a vendor who can lease the item to you. And so you pay for the lease and you continue to use the item for however many years it takes you to get to the end of the longer cash flow diagram. So that then you're terminating both of the alternatives at the same number of years. So here in this image you can see that they were paying a rental fee to use the item, and it was a perfect substitute because it's generating the same amount of revenue for the years that that rental item is being used. And then the third option we used, now we didn't do calculations related to this, but we talked about the concept of it, is instead of renting an item to extend the short cash flow diagram, what you do is you take the longer of the 2 alternatives, so in that case that's option B because it was too long. It still has some useful life at year 6, which is when option A finishes. And so what we do with the longer one, with option B, is we, instead of taking the revenue for the extra amount of years, we sell the item early. So you dispose of the asset while it still has some remaining value in year 6, and that's what the dashed green line is representing, is selling the item instead of using it for the full 9 years. So do you have any questions about what techniques we should apply when 2 different cash flow diagrams have a different useful life? All right, so remember our exam is going to have both concepts and problem solving. So it's a good idea to understand how and why we do things in addition to understanding just how to plug numbers into the calculator and churn through problem solving. All right, what we're doing today is called future worth analysis, and the idea is the same. You've got 2 options, you want to compare them and pick the best one. And the best one is always the one that gives you the most profit. But in future worth analysis, we're looking at it a little bit differently. Instead of discounting all of the amounts to year 0, in future worth analysis, we're compounding all of the amounts to some future year. Now, we have to have the same number of years in order to do this analysis. And so you may need to apply the repeatability assumption to get them into the same number of years. You may need to do contract services. And so those same strategies that we were talking about before, you can apply those in present worth or in future worth analysis so that the cash flow diagrams have the same number of years. They have to be the same number of years and end at the same time. But what this method is used for is sometimes we have projects where the construction lasts a long time. And so it's not just a single one-time present expense, but sometimes you're building a building, for example, and the construction takes 3 years or 4 years until it's finished. And so in cases like that, sometimes it just makes more sense, instead of discounting everything to the present, you'd want to compound the cash flow diagram to the future, and maybe you're trying to find out, after years and years of spending, how much is the project worth at the end of the construction period. So if you're going to build a building and then sell it to someone, you'd want to know how much is the minimum selling price you should accept. And the way you would do that is you'd take all of the revenue, all of the expenses during the construction period and then taking it to the future. So that's one situation where we would use the future worth analysis. And sometimes you want to sell an item early before it's completely worn out, when it still has some value left in it. And future worth analysis can be helpful to you to know how much to sell a car for. For example, if it's being used in business, you will know what you spent for the car originally. You will know what all your maintenance costs have been, and you can even factor in the revenue that the vehicle has generated. And so then that can tell you in year 5, when you're getting rid of the asset, how much you have to receive in order to have that item break even and be a profitable expense. So those are just 2 illustrations of when we sometimes would want to do future worth analysis. Before we start doing some calculations related to future worth analysis, I also want to touch on, just very briefly, an idea that is talking about annual worth analysis. Now, we're going to do a lot more with annual worth analysis in future classes, but this is just a quick taste. And the idea of this is, if you make a deposit, for instance, if you make a deposit in the bank today, how much could you take out from the bank and have it last forever? And this isn't something we've addressed before, because in previous classes, whenever we would have some sort of an investment, we'd make a deposit and then we'd have a certain number of years. And what we've always said in the past, what I'm drawing on the board here is 4 years, we'd make a payment and then withdraw money, and then our assumption has always been this last withdrawal takes the balance down to 0. That we've been solving for some amount where all of the payments are equal, and with the last payment, the account is finished and it all comes into perfect balance. What we're saying with this capitalized cost idea is actually that the payments continue forever. So how much can you take out of the bank so that the amount you're taking from the bank doesn't deplete the funds? And it's actually, as you can see, it's a very simple formula. It's just the basic equation is the annual amount you're taking out divided by I tells you what the present worth is. And so let me give you an illustration of that. If you wanted to withdraw $50,000 a year forever, so let's say that our amount is $50,000. We want to be able to withdraw $50,000 perpetually. What this is saying is, how much should you deposit in the account if it earns 10% interest? Now, you'd be hard-pressed to find something that actually pays 10% interest today. But this is just an illustration, and it's because it's 10%, it makes it an easy number for us. So P, the amount that we should deposit, is going to be A divided by I. So 50,000 is how much we want to withdraw forever, And if we put it into an account that pays 10% interest, that means we need to deposit $500,000 in year 0. And it makes logical sense if you think about it. 10% interest on $500,000 means that at the end of every year, the bank is going to have $50,000 in interest that they have to pay you. Instead of leaving it in, what you do is you just instantly take it out. And so for the next year, they're going to be paying interest on the same $500,000. And so instead of allowing that money to compound and grow in the account, what you're doing is you're just withdrawing each year's interest. So that's the idea behind capitalized cost. Any questions there? All right. I'm glad we're in the computer lab because it's fun to use Excel, right? Let me turn on the on your computers. Question? Forever. Forever, yep. No, you're going to be withdrawing $50,000 every year forever. Because when you take the money out of the bank, just think about what happens in 1 year. If I put in $500,000 at year 0, then the balance in the account at year 1 is the $500,000 plus the $50,000 in interest. And then I take out the $50,000 in interest, and then the bank starts the next year with a deposit of $500,000. And so every year the amount grows, you take out the interest, and it's back to the original amount. And so the payments come to you forever. And by the way, one warning about that. That sounds good, right? Getting $50,000 a year forever. But over time, you'd be able to buy less and less with that $50,000. Why is that? That's because prices are always going up. And so if prices are always going up, think about after 30 years, maybe $50,000, instead of giving you a car, maybe the $50,000 would get you a meal. And so that's sometimes called an annuity. And you always need to be careful about an annuity, and hopefully it's increasing over time to account for inflation. People who are retired, pensioners, have to be careful about that, because if when you retire, the government gives you a portion of your salary, but then it stays constant for the rest of your life, then you could possibly be in real trouble if you live someplace with lots of inflation. And so what pensioners need to look out for is that their pension is indexed to inflation so that their purchasing power stays constant over time. Here is our first example. Let me hand this out to you. We're doing, the example is related to if you're operating a port. And so in the hypothetical here, we have option A, which would cost us $200 million 3 times, 3 payments of $220 million, and that is to completely rebuild the shipping channel. Do you guys have a question? Any questions? No? Okay, all right. So let's take a look at these two options. In the first one, it's a big project. You're completely rebuilding a shipping channel. It's a lot of work. And so it's taking 3 payments of $220 million. And that's one of the illustrations I mentioned, that we sometimes want to take it to the future instead of taking it to the present, as if it is a multi-year construction project. The other option is a lot simpler. It's just to dredge the channel instead of completely rebuilding the channel. And so we can do it more quickly. It's a one-time cost, but the solution only lasts for 3 years. And then we have to do it again. And so in this problem, you're going to use the least common multiple approach, first of all, to make it so that the cash flow diagrams have the same number of years. But then what I'm asking you to find out is which option is better. So take everything to year 9 using the spreadsheet. The formula, you've used, I think, the future value formula before, so equals FV, and the first thing it's going to ask for is the rate, and then it's going to ask you for N. The next thing it would ask for is the payment. Now, what we're going to be doing isn't giving it payments, but we're going to use each row as an individual amount. So we'll skip over the payment field, and then it's going to ask what is the present value. And we'll put in the negative sign because it always automatically flips when it's doing the present or future worth analysis, and then we're going to close the parentheses. So we're going to have row by row. What should you use for n? What is it? All right, so this 220 million, the first payment, what year are we taking it to? We're taking it to year 9. So it right now is in year 0. So when we have our table, we're going to have one column that says year, which is for the current year that it's in. But then we need another column that is what? How many years do we have to take it from year 0 until we get to year 9? All right, I think you've got the idea. So let me hand out the paper. You can get started on that. I'll unlock the computers too. Okay, here's my solution. There's so many ways to format it. You don't have to format it the same as I have. But I've got alternative A with both the amounts and the future worth, and then alternative B with the, and you see I've put net amount here. Net amount. What do I mean by net amount? Why did I emphasize that, net amount? Because if you drew the cash flow diagram, in year 3 you've got both an expense and a revenue, because you have to buy the item over again. It only really lasts 3 years. And so if we go to the cash flow diagram, I'm purchasing, or dredging again. I'm dredging in year 3, and I have to dredge again in year 6. And so the amount that's shown here includes both the dredging and the revenue. As I was circulating around, the most common mistake I saw, and I saw several students who made the same mistake, was they did the dredging again in year 9. Why shouldn't you have the cost again in year 9? Because if you do the cost in year 9, what you're really saying is that then you want to have the revenue after that. And we want this cash flow diagram to terminate at year 9. And so this last revenue of $35,000 is the last thing we need to see. So there's no reason to dredge again if we are finished with the project. All right. So it looks like both options are losing money. And that happens a lot with public projects, infrastructure projects. The government may spend this money so that then businesses can have the channel open and have access to markets. But it looks like the option we should choose is alternative B, because it's the least negative. Any questions about this approach? So here are the things that you need to remember. Some of the common mistakes. For the repeatability, don't buy the item again at the last year. When you're doing the FV function, we need to have the n value be how many years you're moving it, not what year it's in. And then don't forget to put the negative sign in front of the present value, because for some reason Microsoft decided it should flip the sign when you're doing the future value and the present value functions. All right, so let's compare the answer we got. The answer we got is choose alternative B. That's best. What if we do it according to present worth method? Well, present worth method tells us the same answer. Present worth tells us if we discount all of the cash flows to the present, then option B is better than option A. Okay, so if there aren't any questions, let's move on to the second problem. This one's a little more tricky. All right, so your uncle wants to make an investment, and there's two options. Option A will pay $250,000 today, and then your uncle will receive $33,000 each year for 11 years. Option B has a revenue of $25,000 instead of $33,000, but whoever owns it, the seller, hasn't said what the price is yet. So what you want to do is, in the end, after you draw the cash flow diagram, after you find the future value of option A, what you're going to try and find out is how much should you spend on option B so that the two alternatives have the same value. So start off just with the cash flow diagram. Do part A, and then I'm going to pull up my cash flow diagram on the screen so you can see if what you have in mind for the strategy matches what you should do. All right, if you'll look on the screen for just a moment, here's the summary of the problem. Option A, the uncle is going to pay $250,000 today and then receive an annual amount of $33,000. In the question, it says, we want to know the future value. In part B, it says, what is the future value of option A in year 11? And so what I've done is I've drawn on the cash flow diagram that sort of dashed arrow in year 11, and I put F sub A equals question mark. That means that's the unknown we're going to try to find in the cash flow diagram. Now the essence of the problem, you want to find out how much should your uncle pay for option B, because the seller didn't say what the price is, and so you're trying to find out what's a fair price for this investment. And so what you can see is I've got future value of option B is unknown, and the price is unknown. So here's the problem-solving logic that you're going to go through when you do this one. What you want to do is, first of all, find the amount of the future value of A, and then set the future value of B equal to the future value of A, and then make the present value of option B, the amount that he spends, that's the amount that you should pay in order to get everything to work out so that the two are equal. So if you go through the steps on the paper, it says part B, find the future value of option A, and then part C, I give you a hint to use goal seek. Because what you're going to do is you're going to put in lots of different amounts for the price of option B, and I want you to put in and find the perfect price for option B so that the future value of option B equals the future value of option A. So I'll let you think about that and have it digest. But once you get to part C, be sure and read that hint in the italics there, because it'll give you an idea of how to proceed. Okay, some of you have already found the solution. Let me show it to you if you haven't, so that it's on the recording and we figure out what we're trying to do. So this is the cash flow diagram that we already know. This is given. This is what the uncle has as his first option, and so we're trying to do the future value of that. So let me highlight this. So we've got our interest rate is the MAR, the minimum acceptable rate of return. You can see for N, we're doing how many years until year 11, because that tells us how many years in the future we're moving this amount. And the amount itself is what we're using here for the PV cell. And so if I drag that down, the sum of all those is going to tell me how much everything is worth in terms of year 11. The structure of the problem says what you want to do is find out how much should your uncle pay so that option B's total is equal to option A's total. Okay, we don't initially know what that is. This is what we initially have, and then we just have to guess. Now, since he's getting less money, probably we could guess that maybe a starting point is, what if he's spending $100,000? So if I did $100,000, then you notice that the future value is too high. And so that's where the what if analysis comes in, and making a little bit easier for us is, okay, let's see. So it's in the data, what if analysis, goal seek. Our goal is we want this cell to be equal to 51046 by changing the amount that he will pay. And so the amount he should pay is $181,768. Goal seek is very useful. It's a powerful tool. You can use it a lot. Use it in hydraulics, use it in structures. There's lots of Application's a goal seek. Any questions on the solution? I know that for many of you, this class is the last thing between you and the weekend, right? One more? Yeah, but for some people, they leave as soon as we're finished. So I'll let you start your weekend 3 whole minutes early. Yeah? Enjoy it. All right, I'll see you for the exam on Sunday.